In this section, section 10.2, we're going to be looking at a special type of sequence and a special type of series known as the arithmetic sequence and the arithmetic series. So the definition for an arithmetic sequence is that the difference of consecutive terms is constant. We refer to this constant difference as the common difference and denote it as with the letter D. And we hinted at this being important in the previous section, just briefly, so if you don't remember, that's okay. So let's take a look at two sequences and try to determine if they are arithmetic or not. So what I'm going to do is I'm going to look at what's going on to go from -4 to +1. To do that, we added 5. To go from 1 to 6, we added 5. To go from 6 to 11, we added 5. And to go from 11 to 16, we've added 5. So here, we can say this is arithmetic. And that constant, or that common difference, is 5. If I look at this sequence, going from 3 to 5 is 2. To go from 5 to 9 is 4. To go from 9 to 15 is 6. And to go from 15 to 23 is 8. This is not arithmetic because the difference between consecutive terms is different. And in fact, only one of those differences needs to be different in order to say that it's not arithmetic. So all of these differences have to be the same for us to call this arithmetic. Okay. So the next thing we'll do is we'll talk about a formula to find a rule for these arithmetic sequences. Okay. So our rule for finding the arithmetic sequence, so the rule for an arithmetic sequence can be found by a sub n is equal to the first term, a sub 1, plus n minus 1 times d. So let's look at an example of writing the rule for a sequence. So let's write, oops. Okay, so let's say we have the sequence 4, 9, 14, 19. First thing I'd want to do is check to find that common difference. So going from 4 to 9, we added 5. From 9 to 14, we've added 5. And to go from 14 to 19, we've added 5. So we know the common difference is 5. And we know the first term is 4. So now all I'm going to do is plug these into my formula. I'm going to distribute the 5 through. And then I'm going to combine my like terms. So 4 and -5 give me a -1. So there is my rule for the nth term of a arithmetic sequence. Let's do another. So just like we did on the last one, we're going to start by looking for that D. So to go from 60 to 52, we had to subtract 8. From 52 to 44, we had to subtract 8. And from 44 to 36, we had to subtract 8. So here we know the -8 is my D. We know our first term, because it's the first thing on the list, is A1. So we have the first term plus n minus 1 times D. So we'll just distribute this through. And then we'll combine our like terms. So 60 plus 8 is 68. And so we have our rule for arithmetic sequence. Okay with that idea? What if we're given some different information, though, to start with? Let's look at a different example. So let's say that we're given that the 19th term is 48, and the common difference is 3. So again, we have this formula. What we don't have right now is the first term. What we do know is we know an n and we know an a sub n. So what I'm going to do is I'm going to plug those in along with my d and use that to solve for a sub 1. So 19 minus 1 is 18, and 3 times 18 is 54. And I subtract 54 from both sides. I get -6. So now that I have that, I can go back to my sequence, or my formula for an arithmetic sequence, and I can plug in my value for a sub 1, and I can plug in my value for d, and then just distribute that d through, and then combine my like terms to get 3n minus 9. And one more example. So again, we're going to write the rule for the arithmetic sequence. And here we're told that the 8th term is 21, and the 27th term is 97. So here we're not told the common difference or the first term, right? So we know that we have this formula for an arithmetic sequence, and what we have is an n and an a sub n, and then another n and another a sub n. So we can plug these in. So using this one, I would say 21 is equal to a sub 1 plus 8 minus 1 times d. And if I use this information, I can say 97 is equal to a sub 1 plus 27 minus d. And what I have here is a system of two equations. So if I simplify things down a little bit, I'd have 21 equals a sub 1 plus 7d, because 8 minus 1. And then I'd have 97 is equal to a sub 1 plus 26d. And what I'm going to do, I'm going to treat this one as equation A, and this one as equation B. And I'm going to solve this system of two equations by elimination. So I'm just going to do equation B minus equation A. It doesn't really matter which one you subtract from the other, because the a sub 1s would cancel out either way. I'm choosing to use equation B minus equation A so I don't get a bunch of negatives. So the left-hand side, if I have 97 minus 21, I get 76. A sub 1 minus a sub 1 is 0. And then 26 minus 7 is 19. If I then divide both sides by 19, I get that d is equal to 4. Now, this becomes a problem just like the previous one, where we know what d, and we know some point, or some term that's not the first term, but we can use either one of these two terms to find the first term. So again, we have this. So for the sake of argument, I'm going to pick this one, just because the numbers are a little bit smaller. So again, I have an a sub n, and I have an n. So when I plug those in, I can say 21 is equal to a sub 1 plus n minus 1 times d. Again, I know my d. We just found that. So if I distribute that through, I have 4n minus 4. Oops, I'm sorry. This is not... The n there is 8. Jeepers creepers. So 7 times 4 is 28. And when I subtract 28 from both sides, I get negative 7. And now I have the d and the a sub 1. So if I go and do this one more time, I can plug negative 7 in for a1 and 4 in for d. Distribute the 4 through and say a sub n is equal to 4n minus 11. And there's my final answer. Now we'll start talking about arithmetic series. So when we talk about arithmetic series, we have a handy formula for calculating the sum. So the sum of the first n terms of an arithmetic sequence or series is the number of terms times the first term plus the last term divided by 2. So it's like n times the average of the terms in the sequence. So let's look at a couple of examples. So let's say we want to calculate the sums. Oops. So let's say we want to find the sum of 2 plus 7 plus 12 plus 17 all the way out to 3,467. Well, the first thing I'm going to do is confirm that what I'm looking at is an arithmetic series. So to go from 2 to 7, I add 5. To go from 7 to 12, I add 5. And to go from 12 to 17, I add 5. So I can tell that this is arithmetic because the common difference is 5. So what I'm going to need for this formula is the number of terms times the first term plus the last term divided by 2. Well, I know the first term, that's 2, and I know the last term, that's 3,467. What I don't know is the n. So how can I figure out the n for 3,467? Well, I can do that if I know the equation or the rule for this arithmetic sequence. Well, that's easy enough. We didn't have a formula for that. We already know the d, and we already know the first term. So I can just plug these in. 2 plus n minus 1 times 5. I distribute the 5. And I get 5n minus 3. Now again, what I need is the n here. I need to know what term this is. So 3,467 is equal to 5n minus 3. So I'm going to add 3 to both sides. So I get 3,470, and when I divide that by 5, I get 694. So I'm going to take that, and I'm going to plug it in here. So, typing into my calculator then, I have 694 times, and I'm going to do that fraction command, so I press the alpha and y equals, and then I'll do 2 plus 3,467 divided by 2, and then close my parenthesis. So my answer there would be 1,203,743. Oops, whoa. And that's my answer. Okay. What if instead we gave this to you in sigma notation? Well, again, we know that this is going to equal n times the first term plus the last term divided by 2. So we know n, because there's 15 terms. Now to figure out the first term or the last term, I'm going to be using my rule for my sequence. So A1, I'm just going to plug in 1. And for A15, I'm just going to plug in 15. So negative 1 plus negative 43 over 2. So that's negative 330. Okay, there. One last kind of question that we might ask. Is I might ask you to solve for it. So let's say that we have this sequence, or this, I'm sorry, this summation notation. So we have the sum from I equals 1 to n of negative 5 plus 7i is equal to 496. Well, I know that this sum is going to be n times the first term plus the nth term divided by 2, and that has to equal 496. I know to figure out A1, I can just take this equation for my sequence and plug in 1 for n. So when I do that, I get 2. And to get A sub n, I don't know what n is, so all I'm going to do is plug in n for I. So if I go and I put this stuff in, I have A sub 1 is 2, I have negative 5 plus 7n, oops, all over 2, is equal to 496. If I combine like terms in the numerator of my fraction, I have 7n minus 3 for 2, which is equal to 496. And now I'm going to distribute this n through. And I'm going to get rid of this fraction, so I'm going to multiply both sides by 2. That gives me 992. And then I'm going to subtract 992 from both sides, because what I have here is a quadratic equation. So to solve it, it needs to be equal to 0. And to solve this particular quadratic equation, I'm just going to use my quadratic formula. Since the leading coefficient is not 1, it's going to be a long factoring process to get it factored if it indeed is factorable, which it should be if this is a real problem. I know this n should be a whole number, so this should be factorable, but good lord, it's going to be a terrible, terrible, terrible factoring process. Oh my goodness, let's try this again. So I have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's 3 plus or minus and then I have 27785 over 14, and the square root of that is not a whole number. What happened here? made a boo-boo here. I apologize profusely. So I looked at my example and I wrote down the wrong number. This is supposed to be 486. So this is going to change a little bit of stuff, but not so bad. I'm just going to go down and change some of this. 6. And then it should be 972. So that's negative 972. And then I have this should be 27225. And that's what I was expecting. So the square root of 27225 is 165. So if I break this up, then I have 3 plus 165 over 14. I have 3 minus 165 over 14. So that comes out to be 12. And that comes out to be not a whole number, so it doesn't matter to us. So negative 162 divided by 14 is a fraction, so I don't care about that. Have to be positive whole numbers. So there we go. You should now be able to do the worksheet 2 for this assignment. Bye-bye.